guys, so we're back here and we're gonna start by removing a lot of the excess material off of this plate. Um, so yeah, first thing I'm gonna do is I'm gonna measure how far up this motor goes. That's actually bad, I don't need to do that. I'm just gonna measure the size of the motor. So that's a 1.18 radius. So if I just call it a, like a 2.3, no, 2.5 inch circle, we should be able to have an accurate way to remove material. So we'll go to gearbox plate, and what I mean by this is here, let me start drawing and it'll make sense. I'm going to project the geometry of these holes so I can get a circle on them. I can do a circle here and do like a 2.5 inch circle. I might increase this number a little bit, but 2.5. That doesn't look like enough material to make me comfortable, so I'm just going to add a little bit more. I'm going to do 2.75. Just bump it out a little bit. 2.75. And then what I'm going to do is I'm going to come through and I'm going to connect these two with a horizontal line. I don't care what length, I just want it there. Should let me pull it down. I think right about there looks good. I'm going to go ahead and throw a dimension on that just for clarity's sake. Yeah, 2.875. Perfect. And then what we can do is we know we have the 1 inch spacer blocks here, so we can not 1 inch, they're 0.75 inch. So we actually need to cut that material off there. So I'm going to project the geometry of this guy. Trying to think of the best way to do this. I'm actually going to throw a point on this line, and then dimension from the point to here of 0.375, because that's how big our spacer block is. Do another point, dimension from there to there, same thing. And then I can draw a rectangle up. It doesn't matter if it's, as long as it's hanging over the edge, you're fine. It doesn't really matter what size it is. And then once I have that, I'm thinking I'll just take a point from here over, and then we can deal with rounding it out more once we have it. So just kind of like a point there, coming over just like that. Do the same thing here. And then we can see all of this out here that's going to need to be cut. One thing I'm going to do to make it to where we don't have unnecessary lines is we have this trim feature right here. And we can just trim out like that, or a lot of this stuff can get trimmed because we don't actually need it here right now. Like that, doesn't need to be there, doesn't need to be there. This whole bottom of the circle can go. And then we can finish out drawing in with lines. We can just go anywhere along this line that's down here. Draw on a box, finish sketch. I should be able to extrude all of that I drew in. Direction 2, 0.25 inches, cut, looks good. We have that. And then what we can do is we can finish out making this less choppy and more rounded with some fillets. So I'll come in with one there, same thing over here. And then I'm going to try bumping this size up a little bit and seeing, I like that kind of organic looking shape. It flows better in my opinion. So we're going to keep that. Hit enter. Then we might want some in here. I'm actually going to go a little steeper on those. I'm going to bump them up to 0.5. I like the way that looks. And then we can throw a matching fillet to what we had on our spacer blocks, which is a 0.25 down here. That way that radius will match and line up nicely. Say OK. See, now let's hop over to our gearbox assembly and see how that looks now. So you can see it's a lot more streamlined. We've got a little bit of excess material up there. That's fine. I'd rather have too much material than not enough, especially when using this plastic, just to keep it rigid. That looks good. And that looks really nice and uniform, right? So the next step, so we can get this into the drive base we designed, is to change the profile on the rails to match this lineup. So we know that currently this is, if we can measure from here to here, that's currently 0.375. If we move over to rail, how high was our, ooh, that's right. Let's go over to chassis for a second and see if I measure this gearbox plate, these were how far apart? Just so I can get an idea. They were 1.5 inches apart, so I only had 1/4 inch on each side. Okay, so this should work. Rail. Sorry. Gearbox, we can measure. This needs to be, what, 1 inch? And then how far apart are they? 6.5. So rail, we know. Start a 2D sketch on it. We're just going to draw a rectangle that's 1 by 6.5. We've done this once, so this is kind of just reiterating the process. And dimension from here to here needs to be what? If it was 0.375 from the... let's make this easier. Let's go back into gearbox and measure the distance from here to here should be 1 inch. From here to here is 0.375. So 1 minus 0.375, what's that, 0.625? So then in rail, we need this to be 0.625. 5. That's good, and that should put, yeah, that should work. And then from here to here, oh, heck, dimension. I'm out of it today. From here to here should be 3.25, right? Because that's half of 6.5. That looks good. And we'll be able to change this later if I did get something wrong, since I've been making some strange mistakes today. Then we simply put points on all of those corners. Finish that sketch. Do a hole. 0.25. Ooh, watch that. It's set to 0.27. It looked right, but it's not. 0.25. Hit enter. Looks pretty good. Then we can come into chassis. I'm going to actually delete one of these. I can place one of our new gearboxes into the mix. And we can start constraining it and hoping everything lines up. And you notice I left these other holes here because there's no reason not to. I think on our drive rail this year we had mounting points for like 3 different gearboxes. Because it was our first time running custom gearboxes, and I had no clue if it was going to work out the way I thought it would. So we went ahead and had some extra holes in there to where we could switch out to a different type of gearbox if so need be. Or if the need arised, rather. So it looks like our holes line up all the way through that, which is good news for us. But now that this is in here, we can figure out what size shaft we need. So without moving this wheel, because I'm not sure if it's constrained right now or not, but we know it's in the right place. Let's see. Okay, yeah, it's pretty stuck on there. We can measure from here, where our shaft is going to need to end on this side, to here, where it's going to need to end on this side, so 5.84. So we need a 5.84 inch shaft. So just like before, part, sketch, polygon, 6-sided, looks good. Here, 0.5, circle, 0.2, and then 13.75 millimeter. Enter. That looks good. And then we can extrude the center section to that 5.87. 5.87. I'm going to measure one more time just to make sure everything's good. What they say, measure twice, extrude once. Okay, so yeah, see, 5.84 is what I was shooting for. Do the little cosmetic touches, because why not? File, save as gearbox shaft. So now we can come into our gearbox assembly, which is the correct place to do this, and place the gearbox shaft in. So we can constrain in gearbox shaft. And then when we pop back over to chassis, now we have a nice looking gearbox shaft. We can put a bolt in either end of that hex shaft and it'll line up. A lot of times I don't actually put the bolts in CAD. It is important though when you're looking through your CAD design to make sure you have clearance for those bolts. Like, I know if I put bolts here, it's not going to interfere with anything because my belt runs wider than my 2-inch here, so really I could have a bolt head sticking out all the way to this wheel and I'd be fine, right? But you want to make sure that you have the clearance. You got to know that you can get a bolt in there next to that motor. Like, all of that matters so much, because if you can't, you're kind of screwed, right? If I machine this part and it looks great, but I can't get a bolt in it, what use is it to me? It just isn't. So from this point, we can see some of the differences between these two gearboxes, right? This one, it's nice and slim. This way, it's what? Let's measure it. Let's get an accurate comparison going here. This one's 7.25 inches versus this one's 8, right? So we shave 3/4 of an inch off of it. It sits a little bit higher, but you can see that it's kind of all tucked behind this wheel. Like, nothing goes higher than the wheel, so we're the same profile. But whereas before, my motors were here, and like behind this rail, they're up a little bit. That might actually be good because that provides some protection to your motors. Right now, if I was driving over something, I would be able to hit this motor and potentially damage a $140 motor, or 2 of them. So, where over here, it's more protected. The difference is that this would have, you couldn't do something as close to it on top, which this year on our robot would have caused some issues with our design. We could have worked around it, but this was easier for us. So I went with the slim design this last year, but this is a perfectly viable design here as well. So that's it. Before the next video, I'll go ahead and put this gearbox, the same gearbox, on both sides just to unify it and make this the actual tutorial chassis, and everything's been made on the screen recorder. But yeah, let me know what y'all want.